Hi everyone, this is Alice Gao. In this video, I will give you an overview of three related algorithms: lowest cost first search, greedy best first search, and A-star search. For these algorithms, let's consider search problems where we have costs associated with the arcs in the search graph. Recall that the arcs represent actions. Now, every action has an associated cost. Let's assume that the costs are non-negative. Our goal is usually to find the optimal solution, which is the path with the minimum cost. Now, the three algorithms I mentioned are related since they use one or both of two sources of information to guide the search. The two sources of information are the cost function and the heuristic function. Let me introduce both of these functions. The cost function gives us the actual cost of a path from the start state to any given state n. This is an evaluation of our past. This tells us how long are the paths that we have already found. The cost value is an accurate number as we have already found the path and have all the information we need to calculate the cost accurately. In contrast, the heuristic function estimates our future. It takes a given state n and makes an educated guess about how far the state n is to any goal state. More formally, given any state n, the heuristic value of the state n is an estimate of the cost of the cheapest path from this state to any goal state. There could be multiple paths from the current state to a goal state, but we only care about estimating the cost of the best or the cheapest one. We don't care about the more expensive ones. What the heuristic function is doing reflects our goal as well, which is to find the optimal solution or the cheapest path from the start node to any goal state. In general, the heuristic function can be arbitrary. However, for a heuristic function to be helpful for our search, it usually has the following properties. It's usually problem-specific, meaning that it's often based on some domain knowledge we have about a particular problem. It should be non-negative. It's an estimate of the total cost of a path, and we do not consider negative costs. If we're at the goal state already, the heuristic value should be 0. This makes sense as the cost of the cheapest path from a goal state to any goal state should be 0. This final property is important. The heuristic function must be easy to calculate. We should be able to calculate the heuristic value of a state without performing search. Think about it this way. The heuristic function is supposed to help us and make the problem easier, but search is an expensive procedure. If it's difficult to calculate the heuristic function, and if we end up having to do search to calculate the heuristic value, it kind of defeats the purpose of having the heuristic function in the first place. Given the cost and the heuristic functions, we can now define the three algorithms depending on which of the two functions they use. For all three functions, they implement the frontier as a priority queue. The algorithms differ in terms of the order in which they remove path from the priority queue. For lowest cost first search, this algorithm uses only the cost function. It removes the path with the lowest cost from the frontier. In other words, it always selects the best or the cheapest path found so far. The second algorithm is greedy best first search. This algorithm uses only the heuristic function. It removes the path with the lowest heuristic value. In other words, greedy best first search always selects the path or the node that we believe is closest to any goal node. The third algorithm is A*. This algorithm uses both the cost and the heuristic functions. A* removes the path with the lowest sum of the two functions. Technically speaking, lowest cost first search is an uninformed search algorithm since it doesn't use the heuristic function. Greedy best first search and A* are heuristic search algorithms. I'm going to discuss these three algorithms in more detail in the next few videos. That's everything for this video. After watching this video, you should be able to do the following. Define the cost function. Define the heuristic function and describe the desirable properties of a good heuristic function. Define the three search algorithms at a high level in terms of how they remove, which path do they decide to remove from the frontier. Thank you very much for watching. I will see you in the next video. Bye for now.